Hi, I'm Tom Stone, the National Sales Manager of Industrial Markets for Thermal Care. Thermal Care has been in the process cooling business for over 50 years and serves over 50 different industries.
Lastly, we're going to talk about the compressors. And I bring this up last because, one, it's something that you should definitely know a little bit about when you start the conversation about selecting a chiller. But there's so much information with this that I could actually do an entire, though a whole nother presentation for each of these. So we're going to do a quick overview to talk about them, but it's just good to understand some of the key differences and how they work. So we'll start with the scroll. A scroll compressor is a hermetic unit, which basically means it's sealed. So if there's any sort of failure of the unit, it's not something that's repaired. It's more so taken out and replaced. What's good about that is, it's easier work. There's a little less labor sometimes, but it's a low cost unit. So it makes more sense to pull it out and then replace it with a good unit. These units are also very energy efficient, and they cover a wide range of capacities. And these units can actually be used together for multiple units operating in the same refrigerant circuit. And that allows you to increase the capacity range that they can support while also having some levels of capacity control. So now we can turn off some of those compressors, and it's a long time in between they'll need to come back on because we have so many different stages of that. So that's a nice benefit of those. Finally, these are positive displacement. So there's actually a physical mechanism that compresses that refrigerant gas in there. So it's a very reliable unit. The next is a screw compressor, and this is a semi-hermetic. So it can actually be opened up and taken apart, and parts can be replaced or repaired. These units are usually used for a higher capacity demand, so larger systems. They are a higher cost, which is part of the reason why it's nice that they are semi-hermetic, so they can be repaired. These units are very efficient. And compared with the scroll compressor, which traditionally had been a 0 to 100 on or off style of control, the screw compressor had what was known as a slide valve, which allowed it to do some unloading. Now, both the scroll and the screw are available with a variable speed control. So like the NQV chillers that I've mentioned that use a scroll compressor with a variable speed technology, screw compressors can also do that, but because they are generally available for larger capacity systems, a lot of times it just makes more sense to use the traditional slide valve for unloading, which helps save on that electrical cost as well. Finally, this one is also a positive displacement. So there's that physical mechanism that compresses the gas. The last compressor we'll talk about is the centrifugal. And what I've shown here is a Danfoss turbo core. And it's a special unit because it actually uses magnetic bearings to levitate the crankshaft. So there's no true contact surfaces in here. So what that means is we don't actually require any oil for this unit to operate. This unit is a semi-hermetic, so it can be opened and repaired. It's extremely energy efficient, and because it comes standard with a variable speed, and because there's no oil in the system, the speed can be turned down much lower than, say, a scroll or even a screw, because they have oil. They need to maintain a minimum pressure differential to circulate that oil. This unit with no oil does not have that restriction, so it can actually slow down much more and create a huge energy savings beyond even the variable speed technologies of others. They are an expensive unit. It's a very high technology, very precise unit, but they work very, very well and are very efficient. A major difference here is that it is a centrifugal unit, so it does not use a physical mechanism for compressing the gas. It actually is using the rotation of an impeller to force the molecules out away from that impeller to the or to the compressor volute to actually achieve its compression of the gas. And so what that means is it's not quite as forgiving in applications as, say, the scroll or the screw. So something to consider is the type of application that this will see, how wide a variety of load, what the ambient conditions are, and some things like that to ensure that it's correctly applied. But overall, each of these each of these compressors are very good at what they do. They have great, niches that they all work in. There's some overlap there. And so that's where somebody like um, myself could be able to help guide you through the selection to that and weigh the options of, do we need the more robust design, or can we look at something that's a little more energy efficient? So overall, that's really, the key points to consider when you want to start your selection process for a chiller, and to really understand, there's multiple facets. And so each one carries a distinct amount of weight with each different individual in their facility's requirements. So I hope that helps you guys, and thank you for your time.